All right, ladies and gentlemen, I'm trying to get these videos up as quickly as possible. It looks like I may have fallen behind a little bit, but we will work through what we got and we will get what we need to get done. All right, so we're on lesson 2, using the number line to model the addition of integers. Okay, so exercise 1 states, real-world introduction to integer addition. Answer the questions below. Suppose you received $10 from your grandmother for your birthday. You spent $4 in snacks. Using addition, how would you write an equation to represent this situation? Okay, so now we're talking about equations, and this is very important. Okay, if you remember yesterday, I sat there and I showed you, or today, I'm sorry, if you remember today, I showed you that an equation was basically something like a plus b equals c. Okay, the equation has to have an equal sign. Okay, so I want to just write the equation to represent this. So I know that I have 10 bucks and I spent 4. So the word spent, okay, when we see that, we know that this is going to be a minus problem because we're losing money. Okay, but what we don't know is what our final amount is. That's what we still have to figure out, is what our final amount is going to be. Okay, we don't know this, but we can do everything else together. If we know that this is going to be $10, we know this is got to be a negative $4, and then this is going to be our final amount. Okay, these two things tell us very important information. Okay, so I can basically substitute in $10 plus a negative 4. Why am I choosing a negative 4 again? Because this is a spent problem. I'm losing money. Why am I not using the word minus in this sentence? Because it wants me to model addition. So I'm using addition instead. Equals F. Okay. We don't know what the final amount is. Okay. So now that's my equation. I'm done. I've done what I'm supposed to do. I made my equation. Okay. How would you model your equation on a number line to show your answer? Oh, that's easy. Okay. I started off with no money. Okay. Grandma hooked me up with $10. So I've gained 10 bucks. So grandma hooked me up with 10 bucks. Now, I spent $4. 1, 2, 3, 4. So minus 4. So how much money do I have left over? Right. I got 6 bucks. That's all it is. It's not that hard. It's not that difficult. You can do this. I have faith in each and every single one of you that this is going to be easy to do. Okay? All right, let's take a look at example 1. Modeling addition on the number line. Okay? Complete the steps to find the sum of a negative 2 plus 3 by filling in the blanks. Model the equation using straight arrows called vectors on the number line below. Well, the number line is going to be on the next page. Okay, so here's no number line on here right now. So first things first, it says place the tail of the arrow on. Well, where do we always begin any addition or subtraction problem when it comes to a number line? Right, we always start on 0. Okay. Draw the arrow 2 units to the left of 0 and stop at 2 units to the left. Okay, so 2 units to the left means we're going to be in the negative area of the number line, and we already know that the number that we're looking at is negative 2, so that's what it's going to be. Stop at a negative 2. The direction of the arrow is to the blank since you are counting down from 0. Well, that's easy because it sat there and gave us that information in the problem. It's going to be, the direction of the arrow is going to be to the left. Now start the next arrow at the end of the first arrow, okay? Or at, well, where are we going to start at? Right, we're going to start where we left off at, negative 2. So now draw the second arrow blank units to the right since you're counting up from a negative 2. Well, how many units do we have left to count? We got 3. So draw the second arrow 3 units to the right since you're counting up from a negative 2. And we're going to stop at what? What's a negative 2 plus 3? Do 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 1. We got 1 1 1 1. Do I have 1? Do I have 1? Do I have 1? Do I hear a 1? Do I hear a 1? I think I hear a 1. Yes, we got a 1 1 1 1 is the correct answer. We are at 1. Fantastic. All right, so now we got to continue on. Okay, we're looking at F, G, and H now. If I can get F, G, and H in the paper. Here we go. So circle the number at which the second arrow ends to indicate the ending value. Okay, well, that's easy. We know the ending value is 1. So I'm going to circle 1. Okay. So now it says repeat the process from parts A through F for the expression 3 plus a negative 2. Okay. Well, we know we start at 0 because that's where we always start at. I'm going to move left. Am I going to move left or right? Correct. I'm going to move right since this is a positive number. With a negative number, I'm going to move left. So I'm always going to go, since with positive numbers, I move right. So I'm going to go 1, 2, 3 units. There we go, right there. All right, so now I'm at 3 units. And what's the next thing it says? Let's see. Start the next arrow at the end of the first or at positive 3. And then we're going to count back 2 units to the left. 1, 2. Okay, so what do we discover? So what can you say about the sum of a negative 2 plus 3 and 3 plus negative 2? Okay, they're equal to each other. Okay, equal to each other. Does order matter when adding numbers? No, not at all. Why is this? Oh, come on, guys. I know you know the answer to this one. It's been a while, but if you remember, we would talk about the commutative property of addition. Okay? If you remember, the commutative property of addition states that the order of any numbers in an addition problem does not matter because it will not change the sum. In other words, A plus B will equal B plus A. It's the same answer because we're working with the same numbers. As long as the numbers are identical, you'll get the exact same answer at the very, very end. Okay? All right, so let's look at exercise 2, example 2, expressing absolute value as the length of an arrow on the real number line. How does absolute value determine the arrow length for a negative 2? Use the number line provided to support your answer. Okay, now if you remember, absolute value is the measure of distance from 0 to the corresponding number. So I want to know the distance from 0 to a negative 2. Okay, I don't want to know that the answer ends at a negative 2. I want to know how many units it takes. So 1, 2. So my absolute value of a negative 2 is 2. 2 units of distance. Okay, so that's what it's talking about. How does absolute value determine the arrow length of a negative 2? Okay, we know because the arrow length is the distance from 0 to the corresponding number. Okay, that's all it is. Not even that hard, not even that difficult. Okay, all right, let's continue on. All right, B and C. How does the absolute value determine the arrow length for 3? Use the numbers to support your answer. Same concept. We're starting at 0 and we're going to 3. How many units did I travel to get to 3? I traveled 3. So the absolute value of 3 is 3. So the same thing applies. Okay, it doesn't matter where the number ends. The absolute value is the measure of that distance. It doesn't matter if it's a negative 9. It takes me 9 units to go from 0 to a negative 9. Thus, the absolute value is 9. Okay? Let's look at C. Describe how the absolute value helps you represent a negative 2, negative 10 on the number line. Okay, so again, negative 10 on the number line. This is 10 units to the left of 0. So absolute value tells me how far I have to travel to get to a negative 10 on the number line. Okay, so absolute value tells me how far I need to travel on the number line. Okay, that's all it is. All right, so exercise 2. I'm keeping my mouth shut here. This is for your homework tonight. Homework, homework. We will discuss these in class. Okay, so A and B are your homework tonight. Okay. Finding sums. Well, once we get ourselves... There we go. There we go. Find the sum of the integers represented in the diagram below. Write an equation to express your sum. What 3 cards are represented in this model? How did you know? So forth, so forth, so forth. This one again, I'm not helping you. Okay? This problem is going to be for your homework tonight. Okay? You do those 3 problems for me, then we're good to go. The problem set, this is going to be our classwork tomorrow. Okay? We're going to discuss this in class. All right? So let's go over real quick the lesson summary. Okay? On a number line, arrows are used to represent integers. They show length and direction. All right? The length of an arrow on the number line is the absolute value of the integer. All right? Adding several arrows is the same as combining integers in the integer game. All right? And the sum of several arrows is the final position of the last arrow. We looked at that when we had our classwork problem. You saw those three arrows getting all mixed up together. That's the same thing here. The sum of several arrows is the final position of the last arrow. All right? We're going to do these 3 problems in classwork, so don't sit there and stress out about it. I've already given you the other 3 problems. Remember, you can download the textbook from the class notebook. All right? It would cost, I think, $15 if your parents wanted to print it out. However, I just got word that I think we're going to be passing out textbooks at some time this week or next week. So you should be getting your textbook soon. So it's only a little bit longer, okay? So thanks for being patient with me, guys. All right? Short, simple, sweet lesson today, okay? We're going to try to double up later on, all right? But for right now, that's your video tonight.